So now that we've examined some different identities, now we want to stick with those identities and use them to simplify, verify, and rewrite trig expressions. In this video, we're going to be rewriting, and the next one will be verifying. We're going to use the same kind of generic steps in both of them. And they're not necessarily step 1, step 2, step 3. They're just things we can try. So one of the things we can try is to try to rewrite things in terms of just sines and cosines. So then that regards, we're thinking about using those reciprocal functions as well as the alternate definition of tangent and cotangent. Tangent being sine over cosine and cotangent being cosine over sine. If we have fractions, we can try to get a common denominator. One thing to point out is sometimes we won't start with a fraction, but after changing to sines and cosines, we'll get fractions. We can also try rewriting with a Pythagorean identity and either factoring or foiling. So because I'm going to be using the identities that you guys have gotten so far, I would strongly encourage you to have that first set of notes with the different identities on it out with you. If you need to grab that before watching this video, you should maybe pause it and get that first. But in this video, we're going to have 4 examples. So in the first one, I want to simplify this expression. So I'm going to go ahead and use my suggestions here, and I'm going to try rewriting this in terms of sine and cosine. So cosecant is 1 over sine x times 1 over cosine x equals, subtract cotangent, which I know cotangent is cosine of x over sine of x. So notice that I now have a fraction. I have the fraction 1 over sine x cosine x minus cosine sine x. So now I'm going to try to go ahead and get my common denominator. So I notice that the common denominator between these two fractions, they already both have a sine x. What I'm missing or lacking over here is a cosine of x. So I'm going to go ahead and multiply this second fraction, top and bottom, by cosine of x in order to get that common denominator. After doing so, I'm going to have 1 over sine x cosine x subtract cosine x times cosine x is cosine squared x over sine x cosine x. Well, now that I have the same denominator, I can go ahead and put them together, giving me 1 minus cosine squared x on top all over sine x cosine x. Well, as soon as I see that I have a trig function being squared with an add or subtract of 1, that immediately tells me to go look at my Pythagorean identities. And I see inside my Pythagorean identities, I have sine squared x. I'm going to actually put this in a different color. Plus cosine squared x equals 1. So if I subtracted a cosine squared x from both sides, I would be left with sine squared x equals 1 minus cosine squared x. So I'm going to go ahead and I'm going to substitute sine squared x, since those are equivalent, in for 1 minus cosine squared x, giving me sine squared x all over sine x cosine x. And now, since I have sine x times sine x over sine x, I can cancel one of my sine x's out since I have multiplication, leaving me with sine x over cosine x, which is just an alternate definition of tangent of x, which is much simpler than this expression here. Moving on to example 2. Maybe. I'm not sure what just happened to my screen, so I'm actually going to stop here, and I'm going to pick up in another video on example 2.